All right, we are back, and at the end of the last stream, we had just switched to using indices to draw. And the reason that I wanted to do that was just because I want to go ahead and switch to using indices here so that we don't have to do any primitive restarts in order to draw lots of different separated quads. And for whatever reason, quads as a first-class citizen got demoted on graphics cards, at least through Opengl, in Opengl 3.0, I want to say, or somewhere around there. Quads stopped being a thing that you were allowed to use, and we're just down to triangle strips, triangles, and fans, as well as like lines and points. But in terms of actually getting triangles on the screen, that's the way you have to do it. And if you want to do anything else, you kind of have to use your own kind of tessellation shaders, geometry shaders, these sorts of things that you stick on the front end to create your own primitives. And we could do that, but I don't think that's really going to be necessary. What I'd rather do is just use indices. They're very compact. They don't add very much space. And so that will also allow us to do other things if we want to. For example, if you ever wanted to extend this system to draw some more arbitrary shapes, like you wanted to be able to draw spheres, or you want to be able to import some meshes and draw them, this would allow you to pretty much do that for free. And that seems like a useful thing to have as well, so that you can kind of just have generic index meshes coming through. So what I want to do now is I want to take a look at how we're sending those things down, just so I can show the place where this would normally happen. So if you remember correctly, when we look at our render commands, that's what actually has these buffers in it. So if you look at the game render commands, you can see that there's stuff that gets stuck on here as vertex array. There's quad bitmaps and this white bitmap and stuff. We're streaming out our vertices into this vertex array here, and that's where we place all the information that we currently use for rendering. All we really want to do to make this modification is we want to have a way of streaming out those indices as well. Excuse me. So what I want to do here is I want to have a way of having a pointer to effectively an index array. And then when we've got this vertex count here, really what I'm going to change that to meaning is that I want to probably still keep track of it so that when you push these vertices on there, we still know if you've ever overflowed. But really the main thing we're going to be looking at now is that there's sort of an index array that's happening separately here. And what I'd like to do is I'd like to make this index array be shorts. So unsigned shorts, so they're only 16 bits long. And the reason for that is because we're trying to minimize the amount of overhead that we take when we use indices. So when we use indices for a number of reasons. One is so that we can refer to the same vertex multiple times to reduce the memory footprint of that index, right? Because if you think of how we were doing it before, we were specifying vertices for each piece of a thing. So if we wanted to specify two triangles that each shared two vertices, like they do in sort of a quad, right? You have two vertices shared. Well, rather than specify the same vertex multiple times, it could be expensive because there's a normal, there's UV, there's colors, all these things that might be stuck in there. Rather than doing that, what we'd rather do is just specify an index multiple times. That reduces the amount of total space necessary, but in addition to that, it also reduces the amount of transforms that the card has to do, because the card is smart enough to cache the transforms most of the time. So if we tell it to use vertex 2, then a couple triangles later we tell it to use vertex 2 again, it's usually smart enough not to do the vertex shader twice. It's usually smart enough to just cache the results of the vertex shader and use them 2 times. So not only does having indices allow us to minimize the footprint of the actual information itself, but it also allows us to leverage the card's ability to cache, because the card is not really smart enough to cache, and you wouldn't want it to, because it would have to do like trace hashes on the actual vertex data to see that they were the same. Like it's faster to just transform them most of the time, probably, right? And have some kind of hash lookup or nonsense like this. So that's really important to understand that what we're getting out of that is multiple things. Once you want to start encoding topological information in there, indices are really good at that. We want to use them. So I'm going to break this up into two things. What I am going to do is just also point out the fact that if we are using shorts in this situation, if we take a look at the math for a second, we know that 65536, right, standard number, that's the maximum that a U16 can talk about anyway. We don't have to worry about numbers over 65536. What that means is that the number of vertices that we could possibly encode is not going to ever be more than that, right? So our max vertex count, if we were to look at how big a vertex is, we can also see whether we ever want to actually do anything about that anywhere. Like if this is a textured vertex, we can see how big it is. It ends up being, let's see, 4, that's 8, 9, and then another 4. So what is that, 13? Is that right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, that should be really a 14. Yeah. I mean, hard to say, I guess, because I'm not sure exactly what we're going to be doing with these per se. But if we just assume that these things are like, let's say they're going to be under 64 bytes, because right now they are. So if we were imagining these would be 64 bytes, what you can see here is that even if we used every single vertex we could possibly refer to, we're only going to have a 4 megabyte vertex buffer. That's the biggest it could possibly be. So one of the things we might consider doing here is just saying, look, let's get rid of us ever having to actually think about this max vertex count. And instead we'll just say that the max vertex count is always 65536, right? We could do that. I'm not sure I want to do that quite yet. We definitely could do that. All right. So let's move forward and have this actually, let's move forward and actually make this work. This quad bitmaps will be going away eventually, so I'm going to kind of shoehorn it in for now to load the bitmaps per block of 6 indices because we know that these are quads, but we can eliminate that entirely when we go to the next step of this process. So let's start by just doing the basics here. What I want to do is look for everywhere that we are sort of using the vertex count and the max vertex count. I want to sort of augment this now to have the index groups included in there. So that's what we're going to do. Let's see here. So in here where we do max vertex count, this render texture group, I don't know that we care about this at all or what this even is. In fact, what is this? Hold on a second. What are we doing here? What are these things? These things are nothings. So these were us just hypothesizing what we were going to do for groups of textures. We don't need those at all. So let's get rid of that first of all, because those are not there anymore. Let's keep going now. Excuse me. All right, so looking at where we're using the max vertex count. So what you can see here is we're sort of specifying these when we begin the frame, right? We're grabbing these out here. So what I'm going to do is I'm going to follow that lead and just say, look, the Opengl renderer is going to say which of these we're doing. And then we're just going to do this. And what we want to do is where we specify the vertex array, we're going to specify an index array as well, right? So really we're just augmenting the ability to send down vertices. We're now augmenting that with the ability to send down indices as well as the vertices. And really there's not a lot more to it than that, right? It's that simple. So now when we do get current quads, when we specify a quad count there, what we want to do is say, look, if we've got a current quad that's open, we want to make sure that it fits, right? And if we can't, then we just bail. Now, in the future, I think what we want to do here, actually, when we do get current quads, what we actually want to do is just restart in the case where we can't. So I'm not sure why we didn't write it that way to begin with. It's kind of a little bit weird. But if you think about it, it's like the vertex count that we want here is the quad count times 4. And the index count that we want here is the quad count times 6. That's how much we're going to send down for each quad, right? And so it kind of seems to me like this is just a little bit dumb what we did here, because what we can do is say, look, why don't we just look at the current quads and see what it is and then restart if we can't. Oh, never mind. You know why? It's because we don't allocate any additional when we're out, so it doesn't matter anyway. Never mind. I take it back. We don't really need to look at that. But we still do need to do these checks. So if we're doing these checks, we want to look at vertex count here. And similarly, I want to be able to say, look, if the index count isn't going to work, then we're in trouble here as well. Right? Okay, so moving on. I suppose that's probably it, but let me just double check for the places these are used. Here's where they're allocated. Yeah, so this is all. So what I'd like to do here is where we pass in max vertex count there. And actually in here, we don't need these anymore, right? These aren't used at all. Yeah. Pretty sure only max vertex count is used, right? Or it should be used when we allocate the memory. In fact, all of this stuff is old, right? Yeah, so max quad count per frame is getting passed in here. That's the only thing we actually need now. So all of that was just old vestigial code that we forgot to remove, right? We just hadn't never gotten around to deleting it. So now in here, you can see that we can do the same thing we did before. Based on the max quad counts, we can basically, based on whatever it says the max quad counts were, we know we can use the indices to refer to those. Now, here's a problem that we would quickly run into. And that is that for the max quad count per frame, if we pass a large enough number, we will blow out the size of the indices, right? We won't be able to specify enough indices because the indices can only represent 65536 vertices. And so if we allocate more than 65536 vertices, we can't refer to them anymore. But that's actually okay because we can use different base vertices. So we can slide our array window up. So we will be able to actually reference more than 65536. We just have to keep our index count. We have to keep our indices low enough that they don't overflow that. So what we'll do is we'll just keep building up indices until we've pushed too many vertices on, and then we can sort of, like I said, just move in sort of batches where we kind of slide our window forward. So we don't really need to worry about this, the fact that these will overflow the index range, because we'll be able to handle that, and I'll show you what I mean by that later on as we go. So here's our max stuff, and I'm literally just allocating a sideband array here for our indices like so. And there's nothing to it, right? This is all we're talking about. So once we do that, we should now have a thing that excuse me, that gives us exactly what we want for streaming out these indices. We're just not using them right now. And also the other thing we have to do is we have to make sure that our Opengl render actually has the members in it that we need. So I haven't done that yet, right? You know, here's our texture vertex, or you know, this sort of stuff. We need that index array now. So there's our index array. And we also need those counts. So once we've got those, we're good to go now. And now we've got an index array. It's prepared. We're checking for it and all that good stuff. It's just no one's putting anything in it yet. So now what I'd like to do is I'd like to go ahead and start by backing that number down. So basically, like if we go into the Win32 renderer test, and we look at what we're doing with the, if we go into the renderer test and we look at what we're doing with how many things we pass on, right? We've got a maximum quad count. What I'd like to do is say, look, I want this quad count to actually be really small temporarily. I want to say the whole quad count has to fit inside one 65536 vertex batch. I know this right here is 65536, right? That's how many quads, that would be 65536 quads. We know that each quad is going to take 4 vertices, so we know that this number is 4 times, right? This total number is 4 times too high. So we actually need to back it off by 2 powers of 2. That's the maximum number of quads we could sync per frame. I'm then going to compile and run this. We should then hit the assert. It should say, oh, now you're you're trying to do too many of these primitives per frame. Sorry, we can't do that. So I'm going to go ahead and run that, and we should hit that assert. There's that assert right there. So what I'm going to do is just back off the number of grass elements that we're putting in there to take the pressure off of that while we do the switch to indices. And that way we can make sure our indices are working properly when there's just one array, and then we'll switch to the sliding window when we've done it. Again, this is breaking the problem into 2 steps. You always see me do this, and the reason for that is to eliminate the places where the bugs can be. If you do in steps where you test each step, then you don't have to worry about bugs that can operate across those steps. It limits and focuses your ability to debug much more specifically, and it just reduces the total time it will take you to debug it. So that's all I'm doing here. So I'm going to go ahead and change this this cover index to just not draw any grasses. That should eliminate any work we were doing that goes over that texture limit. So here's the world without any of the grasses being rendered, and that definitely gives us what we need as far as a single buffer workflow. Workload, sorry, not workflow. Okay, so switching back to the Opengl renderer, now what I want to be able to do in here is something where these are all, these draw elements calls are actually all just based on an index buffer that gets passed in. So rather than the quads ever having anything to do with only telling me sort of these vertex offsets, what I'd rather do is say, look, we come through here, you can see us specifying this buffer data. Each one of these is specifying a set of triangles that's, each one of these buffer data calls is sending down this many vertices, and then you can see me referencing those vertices here using these arrays. What I'd rather do here is send down the array of indices as well, and then use that array, right? That's what I'd like to do. Now, I want to do that in baby steps too, so before actually doing that, what I'm going to do instead is I'm going to just use the offset in here to do that. And so to do that, what I need to do is augment our renderer structure in here just a little bit to give us the index offset as well. So if you look at the quad structure here, what you can see is this tells us where in the vertex array we are. What I want to do here is I want to say what's the index array offset as well. And this is just saying tell me where to start, okay? And so in order to have it tell me where to start, what I need to do is I need to, when I specify this index array here, rather than using this old one that we sort of put in place for the old draw arrays, what I want to do is sort of nerf that and instead have a call to draw elements that uses that pointer. So we know that this index array offset, so the thing in the actual, so much like here where we were using this sort of this GL buffer data to send down all of this stuff, and then the vertex index itself was coming off of the entry. See, vertex array offset, that's where we're starting. What I want to do is I want to take that index pointer and I want to actually have that index pointer be offset by the index array offset, right? And when we do that, we now know that we don't want this index array. We want the actual index array that this would be referring into, which itself is the one that comes off of the commands, right? It's the one that the game filled out and that's the index array that we're looking into, okay? So that should give us a way to just draw out of a prefab array that we go through, and we no longer need this vertex array offset thing to really be encoded the way that it is. We can change that encoding quite a bit if we would like, but we're gonna have to do that in stages, again, just to avoid the possibility of bugs creeping in there. And to be more specific, what I mean by that is that if you look at how this buffer data gets sent down, we send down all of the data here in one giant step. And then, you know, and the reason this is kind of dumb is actually this sends it down multiple times potentially too. We only really need to send this down once. So this is just kind of dumb. This could just be sent down here. In fact, why is this happening here? This is not right at all. Yeah, so hold on one second. Put a little pause button on everything I said. Why do we still have that there? Right? It's a little odd. Are we sending down that buffer every time for geoquads? That's super busted. What we really want to do is to do it here, right? I mean, that's what we actually wanted. So I don't know why we weren't doing that. Probably because we weren't being very smart about which buffers were being used when. But this is what we actually wanted, right? I'm not sure what. So that change seems like it does seem like we're getting some problems with our depth peeling, though. So here's what I think's happening. Where's our begin screen fill? Yeah, so you can see the problem that we're going to have. We only have one array buffer here, and the problem with only having one array buffer is that we need to have, like for example with this one, where we're using a different array buffer to send down our stuff, we end up in a bad situation where we need to be able to refer to this one buffer multiple times. So the thing about that is Opengl lets us do that just fine. It's just whichever buffer we bind, right? So you can see here we only have one array buffer. If we just have multiple array buffers, we'd be fine. So what we want to do is have a vertex buffer and like a, let's take a look here what our other ones are. So, I mean, you can see actually, if you just look at the other buffer datas, that they're actually all fixed buffers. So if we want to, we can actually just specify each of these buffers as one of the buffers. So we've got a couple different ones here. There's the screen fill buffer, which is this one. So let's just make that. And then we also want the sort of post, I think that's just the post processing stretch, right? The composite. And those are the buffers we use. Since these don't change, they're the same thing, right? We should be able to just create them right off the bat. So for example, when we gen these buffers here, what we'd rather do, instead of calling this bind buffer, what we'd rather do is just make these right here, right? So bind the composite vertex buffer like this and specify that data. Kind of like this, right? And then we can just bind that buffer here. So we don't have to send down a buffer stream. We just bind a buffer and use it. And the same can be true for our screen fill buffer. This is just all, this has nothing to do with the indices. This is just better in general. We should have done this before. So this was just, we didn't get to it, right? But this is just all better in all cases. So if you look at the other places that we specify this, I'm not sure, what is this here? That's just the one we're editing on the other side. So there's only one other call to the buffer data that we care about, which is right here. And so the same is true for this. Wait, this is the same. This is exactly the same. Is it not? That looks exactly the same to me. So actually, we don't need the composite one at all. We can just use a screen fill vertex buffer in both cases, and we only need, that's the only one we need. Right? So what we want to do now, I think, is if you look at GL buffer data, and you take a look at what it actually specifies, there's sort of this usage note, and you can see those various usage notes on here. And we don't actually need to modify this buffer. This one stays the same. So GL stream draw is like the wrong hint. We are not going to be doing it none of this stuff is as it should be. So we want like a GL static draw. Yeah, right. So we want this for this buffer because it's not changing. It's like we always use it exactly the way it appears here. So it doesn't need to go that route. Okay, so the screen fill buffer is there. The composite buffer is here, but we know that that's the same one. So we should be able to just do this, which means that for the rest of our stuff, what we can do here is just know that when we submit this, we will bind our vertex buffer here and send it all down. And then whenever we go to draw in our texture quad set, whenever we go to draw, then we just bind the vertex buffer in this case here, right? And that should basically do it. So we want, oops, that's supposed to be screen fill. We want to put space for storing this, the index that Opengl gives us back. We actually have to have that in here. That was just stored in here, right there. So I'll just place another one in there. So now we have the, oops. So now we have the other one. Okay. And when we're calling this, it looks like we need to know the pointer to Opengl because we don't actually know where to get that screen fill buffer handle otherwise. But that's pretty easy. Okay, so now we should be able to use those arrays sort of in a more coherent fashion. Where, okay, don't ask me why I inserted a 6 right there in place of our code. And so now we look correct again, right? And now we're not calling that buffer transfer stuff a bunch of times. So that's good too. So the other thing I want to do there is I want to see what effect that had on our ability to have speedy rendering here, because I realized I didn't know we were calling that multiple times. That's really bad. That means we may have forced the Opengl to submit that buffer multiple times for no reason. And that's just really stupid. So, okay, let's just check. I want to make sure that we don't have, that we didn't just get a speed win from that. right, is what I would like to do. So now we're pushing down a ton of cover again. And actually, like, it is strangely quite a bit zippier, honestly, it looks like. So I'm not sure how much of that might just not be in shader cost, really. So that was probably a pretty big deal, to be honest with you. I know we weren't really taking any timing, so that wasn't supposed to be part of the optimization thing, but that was an important thing to get rid of. We really didn't want to have to be doing that in that way. I want to take a look just real quickly at the Z-bias program here. I would like to go ahead and nerf the lighting call just temporarily. So in here, what I would like to do when we're doing our lighting, right? I would like to sort of switch this around a little bit just temporarily. I'd like to see what happens if we just get rid of the lighting and instead set running sum to just be full lighting. Just so I know that the shader isn't taking an inordinate amount of time. It doesn't look like that really affected it much, right? It doesn't seem to be anyway. Well, I guess I don't need to do that. I'm going to put this back out because I'll be switching that back around a little bit later on too. I wonder, well, actually, I can probably make that change even if we're down. So lighting disabled is actually a compilation switch we can do there too. So I suppose I could just set lighting disabled as well. So in the Opengl renderer, where we've got the lighting disabled, is that actually already happening? Let's take a look. So when we actually compile that program, let me see where we do. So that's just going to be the lighting disabled parameter. So when we do compile Z-bias program, it's like depth peel and then lighting disabled. So it's just lighting disabled whether that's turned on. So what we could do to disable lighting entirely is just make sure that our settings are always set that way. So inside the renderer test where we set, for example, whether we wanted VSync rather, we could just say lighting disabled equals true. And now we should never call the lighting at all. Okay? So in theory, and again, I don't know, but in theory, we should be seeing some slowdown due to texture changes here. We would like to take some profiling about that if we could, but I don't know to what extent we really can. What I can tell you is if you look here at the speed at which it's rendering at the moment, and again, we actually do have a printout of how slow it is, right? So if we looked at this, we could see, you know, if we forced it to shrink the display dimensions down, what the difference in speed is, right? Just to see to what extent it seems sensitive to that. And it doesn't really look particularly different. To me. And I'll just try and I'll verify that that's actually the size that we're getting. Well, maybe I won't. Where's our settings have changed? Let me just set a little breakpoint there. So let's just make sure that we're using what I think we're using in terms of the sizes of things. So we should only be creating buffers of that size. So for example, when we go in here to create like whatever the depth is of our frame buffers, yeah. So all of this stuff should now be pretty small. So I think that just works. And we are now, like, that should mean that we're really not spending much time in that shading. Okay. So let's suppose we want to kind of move to the next stage of things. Also, let's make sure we're in O2 mode. We are. So inside the renderer, the next thing that I was going to suggest is that, excuse me, I would like to now use the indices more directly. So I would like to use an index buffer coming from the app rather than doing one of these every time. So what I'm going to do is I'm just going to set up something that takes a look at those indices and uses them. Now, like I said, I don't want to have all the grass in here. I don't want to have 60 as the amount of grass. I want to do 0 as the amount of grass and start with something like this. There we go. Where I can be more specific about always having everything in a buffer first. So we're going to switch from doing this stuff. We're going to switch from doing that in an index buffer that we create right here, and we're going to switch to one where we can just send down the index buffer, right? So what I want to do here is pretend, okay, let's suppose we had an index buffer. How would this work exactly, right? I believe, I don't know if it's really called that, so you'll have to bear with me for a second while I look up what the Opengl term is for it. It's this one actually. Element array buffer. And so if we have that still defined, it doesn't look like we actually do. So in here, where we define when we specify one of these buffers, I'd like to be able to specify the element array buffer so that we can sort of say, look, here's this other array of indices. I want you to use those. I don't remember if that's the most compatible way to do it or not. Let's take a quick look here. Yeah, so it looks like that goes back a long ways. Here's the Opengl ES 2.0 docs. So I think GL element array buffer should be fine for us. So array element, oops. So this is the actual identifier we need. Conveniently, the one right after array buffer. So we should be able to actually bind the index buffer now. And I thought we had specified that as something that was off of Opengl. Index array, sorry. Oh, no. But we're talking about the buffer here. So we need to create one of these for our indexes, like so. So we've got a vertex buffer and index buffer. We need to bind our index buffer, right? And we also need to send it down. So just like we were doing before, where we specify the buffer data, we need to do the same thing for our indices. So we need to do GL array element, element array buffer. We want to specify that in exactly the same way. Only this time it's like this, where we specify a certain number of U16s, right? Otherwise, everything is exactly the same. Similarly, where before we're doing our bind buffers to create the initial versions of these things, we want to do the same thing here for that index buffer, right? So that we can have a separate handle for this buffer that we're going to use to specify those indices, and then we can actually draw from them later. So that will set all of our indices to be drawn, but of course, unless we actually refer to that buffer, I don't believe anything will happen now because we're still passing a pointer. Although it looks like, hold on a second here, what's the complaint? I wasn't expecting an error. I was expecting it to just kind of not use it, but I'm not sure what the error actually is. Let's take a look at the message there. Encountered an out-of-memory error. That seems like not true, so we probably passed the wrong thing there. My assumption is that's because when we actually were specifying let's just take a look here. When we were actually specifying the index count, we did something like maybe you can't say that the buffer has 0 things in it. Or it means that it actually was using this thing, which I don't know if it actually is or not. Let me quickly just check that. So suppose we wanted to know if it was actually trying to use this array. Well, what we could do is just make sure it doesn't by unbinding it. So now there's nothing bound to GL element array buffer. So hopefully that'll let me focus my debugging on the thing that's actually the problem. Okay, so I guess what's happening here is the thing that happens in OpenGL. Again, this is one of the reasons OpenGL is bad, is because there's so much backwards compatibility stuff in it. Because I think a lot of the parts of OpenGL are actually designed pretty well. In some cases, if you just pick and choose certain parts, are designed pretty well. But there's such a breadth and a long history there that some things are bad. So I think what happens, if I remember correctly, it's very idiosyncratic. If you bind an element array buffer, then I think what happens is this call actually reads from that buffer, but it uses this pointer as an offset. So this pointer then becomes basically how far into the buffer you actually wanted to start, right? I'm pretty sure that's what it was. So if we wanted to make this work, this goes away, right? We can do that just by saying, okay, these indices here, this is actually technically an offset. So even though we're casting it to a void star, it's not a pointer. What we want to do is take that offset, so this thing, and we want to start at that offset, right? And then we want to move up our indexes based on that. So really the way to think about this would be this becomes a loop now over the indices. This is really an index now. That sounds weird. That's what it is. It's going to go up by 6. That's just what it's going to do. Right? And we're going to start at the index array offset specified here. Now what we need to do in the quad bitmaps is a little harder, but that's okay, because I'm just going to say that for now we're going to use all the same quad bitmap, right? So temporarily before because again, this is something we want to change, I'm going to say that in here when we grab out the texture, what I'm actually going to do is just grab out one of the random textures in the thing. Just the second texture you ever specify for some reason, right? I don't know. Whichever one it is fine with me. So we're just going to pick a random texture here to apply because we are going to change how we're specifying this. And then when we go through here, I'm just going to pass the index array offset as whatever the index is that we're currently on, like that, right? And that's how many indices in we want to be. Now I think that has to be a byte offset. So I think we want that to be like this. But that's about it. Okay? So now what we need to do, because I think that's correct, now what we need to do is actually put some indices into that buffer. Because what we're going to find is now that buffer is just filled with garbage, right? Oops, we still got our... am I accessing off of it for some reason here? Oh, well, I don't know if that buffer's clear. So let's fill it with indices first, and then we'll debug it. So what we need to do is every time we push a quad in the renderer, we need to actually go into the to the index buffer as well as where are we here? There we go. Every time we sort of want to access any kind of quad, like every time we go into the push quad here, we want all of our calls to push quad to be filling the index buffer in addition to the vertex buffer. So much like how in here we do textured vert star vert and off we go, in here we also want to do the same thing. We want to do like index equals index count, index count plus equals 6, and we want to assert that we line up okay. We want our index out to be at that place. And then when we put these out, we want to do exactly what we did before, right? So the vertices, like exactly the way we did the vertices before, we want to put those out here. So we want to do like index 0, oops, 1, 2, 3, 4, 5, like so, right? And I suppose if we really wanted to do this, you know, we could do this. I mean, dividing by 6 is not a great idea, but it's okay, it's temporary, right? So we can do that, and that still ends up being the correct thing, and we can write that bitmap in there as well. So no harm, no foul. So when we write out these indices now, we need to actually write out what these vertex indices actually are, and so we need to write out vert index relative things. So here's our vert indices, and now we know that these things actually go the other way around from how I thought they went, so they went like top down instead of bottom up, which is kind of nuts. That's what they do. So if they go top down, again, we want, so we're going to want 0, 1, 2, right? And then we're going to want 1, 2, 3, I think, if I'm not mistaken. These, of course, need to be 16 bits, and we should assert that. Oops. So this way we would know if we ever tried to overrun those bounds, we'd get an assertion here. And that's going to be relevant in a little bit, right? Okay. So what this looks like, interestingly enough, is apparently filling the index buffer now at least kept us within range. So that's kind of cool, actually. I wasn't necessarily expecting that to solve that problem. But we still have to actually now get stuff on the screen, right? And there's a number of things that could be wrong here, including our vertex indices, like including all sorts of stuff, right? So our vert index here, we know that that's the base vert index off of the vertex array. So I believe that is the correct basis here. Also, I don't know if this winding order is correct. I gotta go write it down, but it doesn't matter because if it was incorrect, we'd just be seeing the back faces instead of the front faces. So the fact that we're seeing nothing lets us know that that's not exactly the problem, right? Now let's just make a couple quick adjustments here. Let's make sure we're using a white bitmap. That way we know that we're not just picking a texture improperly. So we're not seeing anything, so that's means that that wasn't the problem there, right? And then finally, oh, well, here you go. So these we're saying unsigned int for some reason. We don't want them to say unsigned int. We want them to be unsigned shorts. So I don't know why that was still saying that. We just forgot to change it. So now when we look, it looks like we've got one of our triangles wound wrong still. Let me just write this out now. So the order of these we determined is actually not this way. It's this way, apparently. Apparently. So if it goes like this and we want to do that, we would do 0, 1, 2 for this counterclockwise triangle. And then we would do 1, 3, 2 for the other one. Right? And so that should draw all of these things through the index buffer now. And again, this is an index buffer we're passing down from the app, and that looks about right. And now if I go over to the actual render again and just put back in the quad bitmaps, we should be good to go. And that looks about right to me, so I think that's all good, right? So now what we can do is stop doing this entirely. So now what we can do is actually draw a huge batch, and the problem will be that we won't know what bitmap to use. But again, if I just, temporarily speaking, say that the texture that I want to use is actually going to be, and I'll nerf this temporarily, right? Like this. What I can do is say, all right, let's use a texture. Oops. That we're going to pretend that it's okay. We'll just use the white bitmap instead. So we do white bitmap here. Instead of the actual bitmap that we want, we're always going to use the white bitmap. If we did that, then we could actually draw this in bulk, right? Because now we could just say, look, start here. Like, this is where I want you to start. And this is how many I want you to draw. Right? But now, just don't bother with a for I loop. Tell Opengl to draw them all. Right? And that takes us from having one draw call per sprite to having one draw call per entire scene pass. Right? And so that looks like this. And again, it's totally correct for everything other than the fact that we don't have a way to vary the textures. And that's why we want to talk about things like texture arrays, because now what we want is some way to vary our texture in some way that doesn't involve having to restart that primitive, right? Having to restart that loop. And so let's take this one at a time. If we take a look at the frame speed here, we can see that we're still a little slow for reasons we really just don't know what they are. And that's the place where we'd really like to get some profiling in here, because we just don't know where these milliseconds are going, right? We do not fundamentally know why we aren't hitting 60 frames a second, for example. We have no idea. And furthermore, it's a little weird because it looks like it's fill rate related. So again, it could be because of the multi-sampling, right? It could be because of our shader is screwed up in some way. We don't know, right? So we have no idea what the reason for the slowness is, and we're going to have to investigate that separately. But what we can see is like when we get down to a smaller size, then all of a sudden we do run at 60 frames a second, right? And it'll be interesting to find out why. That's where we're going to have to hope we can get Insight working relatively well. All right, so if we push that process further, just to see what's going on, now the next part of this process is getting up above the unsigned short limit. Because what we're going to hit then at that point, now that we move to that, is we're going to see a problem where when we do inside our renderer, when we go to render, we'll blow out that that index rate really quickly. So now we want to scale up to being able to do tons of these things. So we want to be able to put that 60 in here again. And what we're going to find is as soon as we do that, we're going to blow out the addressable range for an index, right? That's just not going to work. So what we see here is, again, we haven't exceeded the maximum number of vertices. We have room in the buffer to put another vertex. We haven't exceeded the maximum number of indices. We've got plenty of room in the buffer to put in another index. What we don't have is space in a U16 to refer to a vertex, right? That's the problem. So what we need to do is find a way to get our U16s to be able to render up into more parts of that buffer. So what we can do here, I believe, and you'll have to forgive me for not remembering off the top of my head how to do it, because again, Opengl is kind of a sprawl of ridiculousness at this point. But what we want to be able to do now is pass an offset so that we can say, look, we're using these two buffers. All the vertices are in one buffer. All the indices are in the other buffer. There's no problem with that. Everything fits, okay? So we don't need to talk to you about multiple buffers or anything like that. But because we're using U16s, we need to do this in a couple different batches potentially, where we draw 65,000 vertices at a time, and then the next 65,000 vertices at a time, you know? And so what you can see here is like, say this GL draw elements base vertex, right? So what you can see here is that's almost exactly the thing that we're looking for. This call does exactly the same thing as the other call, but it allows us to pass in a number that shifts up all of our indices past the numbers that they could normally hit. So now we get the ability to add a 32-bit offset to our 16-bit index. And that can slide us anywhere inside the buffer that we need to be, right? So we don't have to do this. We could use 32-bit indices, but it's pretty easy for us to not. And it's just less data that has to get transferred, right? So if we wanted to do that, how would we do it? Well, luckily we kind of know when we call get current quads, we kind of know what's up, right? What we can do is say, would this set of quads exceed the maximum number? So would the current quads that we have right now exceed the max per batch? So what we want to say there is, look, why can't I get up? There we go. If the maximum thing that can fit in a U16, and maybe I'll subtract 1 from that just because I don't actually want to ever fill entirely like the space, because if we ever did want to use primitive restart, I'll just leave 1. So if the maximum number we could hold in a 16-bit integer, more or less, If I divide that number by 4, then that's how many different vertices I could ever reference. So I'm going to look to see, would we exceed the number that maximum quads? Would we exceed that by what we're being asked? And if the answer is that we would, then I need to push a new one on. So I'm just going to say, look, forget about the old one at that point. It's done. It's over. I'm not going to talk about another one, so don't expect me to, right? Then I'll go ahead and say push a new one on, start it all over again. The vertex array offset is going to be whatever this vertex count is here, right? And off we're going to go. Okay. So what that allows us to do is now inside the Opengl render pass, when we send these down, we know that we can now call this call instead, which is GL draw elements base vertex. And what we can do is pass that down as the base vertex. So this entry knows that all of its offsets start at this number. And then when we actually push our quad on, instead of using this vertex count as the vertex count that we base our indices off of, right? So we're not going to use this vertex anymore. We're going to use a different base index, and it's going to be the actual quads the number that's in the actual quads itself, right? So in here, where we do this entry quad count, right? It's actually going to be based off that number. So right here, we're going to say the current quads that we're talking about, that quad count times 4 is going to be the actual base index, because we don't anymore. Actually, you know what? I don't even need to do that. That's not what I wanted. I can just use this. It's really just that, right? So what I can say is, hey, the first vert index that you're going to use is this one now. That vertex array offset is the basis. So whatever vertex index you were going to use, subtract away whatever this current quad group's base vertex index is. Just subtract that away, and that's your index. You know what I'm saying? Okay. So now we just need this function, because this is a function we don't have. So what I want to do is go ahead and grab it. And this is what it looks like right here. So where we were doing our Opengl, when we basically at this part we have a big lemon grab where we go through and lemon grab all the APIs that we want to take here, that we want to use. And so I'm just going to go ahead and put those in here. I think that's it. So I'm going to say we want that. There's our GL draw elements base vertex. And then what I have to do is somewhere here eventually I have to actually ask for it. Okay, now that was a lot of stuff to add, so probably we're going to run into some trouble here. And also, that assertion needs to be modified to actually be correct. It's not correct anymore. So we need to sort of create a temporary here called base index. And that's the thing we want to make sure that we can still equal after the cast, just to make sure. So that's, I mean, it looks pretty darn good, actually. Um, and you'll notice we're actually still running at a high frame rate, high in this case compared to what we were running before. I don't really know about the texture fetching there, though. So I do think when we do render Opengl here, let me just do in renderer test. Let me go in and make sure that whatever we're doing is not. Let me just make sure that whatever we're doing is not just because we're using the white bitmap now. I'm going to try using like the grass bitmap or try to find a different bitmap to use. I don't know how to get it exactly, but I'll pick one randomly. Oops. Quad bitmaps. This will probably be grass. Most of the things we send down are grass, so you know. So what you can see here is that really just getting rid of that dispatch totally fixed our problem, right? You know, there's probably a bunch of things we're still doing wrong in terms of frame rate here, because you can see we still aren't quite as good as we probably should be. Of course, we can't tell because Windows is still capping our frame rate, even though we asked for VSync to be off. They totally decided to ignore us. Oh well. But what we can see here is that we're not getting any of those ridiculous slowdowns. We're running basically the same frame rate we were when we weren't putting any grass in, despite the fact that now we've put in 60 grass bitmaps per tile, right? So we can immediately see that the dispatch overhead was a huge issue for us, exactly as we thought. And so all we really need now to finish things off is a way of changing the texture every time we swap, right? Every time we go to a different quad, we need a way of changing the texture, and we need texture arrays to do that, or a texture atlas, right? Those are the only two ways we can really make that happen. There is a third way that I'm just sort of saying that we're not going to do, and that would be to use bindless textures. And the reason that I don't want to do that is just because I'm afraid of that it won't be broad enough support for it. So I think I would really just rather use the texture arrays. So what I would like to do is I'd like to go ahead and set up the texture arrays. I don't think I have a huge amount of time, maybe 45 minutes. So it's a little tight in terms of getting that done. But really that's the main thing that we haven't done yet, right? Is a way to make this work. And so what we'd like to do here is basically, when we do this bind texture, we'd like to do just a single bind texture where we just say, this is the texture we're binding, and it's over. And then each of these draw calls here would, each of the vertices pulled out by the draw call would actually contain information in it necessary to pick. So let's take a look at what would happen there. I want to look at the vertex descriptors here. We haven't looked at these in a while. So you can see here vert PID, vert NID, vert UVID, like this stuff, right? Get attrib location, that sort of stuff. So what I'd like to do here is extend that in a sense. So this vert UV, I'd like to actually have an additional thing in here that allows you to get another value which is going to be used as a texture array index. So in terms of which texture we're selecting there, the vert light index, what you hopefully will be able to see, is that we only really use that in one program, which is right here. And this is our general like fill function, right? It's the Z-bias program, which does all of our filling. So what I'd like to do here is suggest that maybe what we can do is pass in another value into the front end there that will get used here. I don't know. Yeah. So there might be other ways that we would want to think about this, again, like I said, because we don't need to actually, it doesn't need to be specified per index. It can just be something that's specified once and done. It's the same as vert light index in that sense. So if I just call it texture index here, then what'll happen is we're going to talk about it being passed in this way, even though it's not super necessary because each vertex doesn't need to specify it. Each triangle can specify it uniquely, right? And so that's the part that's a little bit wasteful here that we're not addressing. But if we take a frag texture index in here, then what we would be able to do is use that texture index when we're actually doing our textile fetching. So for example, right in here for text sample, we could use that to fetch into the texture right here rather than just into a flat single 2D texture. So what I'd like to do is make it so that we can pass that information down. So basically everywhere that we see that light index, that vert light index happening, I would put in vert texture index. Like so. So we're basically just doing the same thing here. This is still being unsigned short because we're not going to allow more than 65,000 textures. That ain't going to happen. Again, just grabbing those out. Just lemon grabbing this right here. And there's that. I'm gonna call this vert line index here. Sorry, vert texture index. Again, just because I want it to kind of line up the same way that it was before. And so that's really what we're talking about. I don't really know that we'll need anything other than that. Where is that at? There it is. There's texture index. So now all I need to do is actually go in there and put that texture index into the definition of our renderer's vertex format. So in here where we do, where we've got the textured vertex, where is that thing? Textured vertex, textured vertex, textured vertex. I know you're in here somewhere. There you are. So what I want to do here is have a thing where we're like texture index. And again, same as this, lighting and texturing are the same. They wouldn't have to be per vertex if we wanted to make the renderer more advanced and have a per primitive buffer that gets read out of that's just replicated multiple times, right? So that's that, right? And in theory, if we call this now, nothing should happen. I don't think. Oh, well, I take it back. Where's our errors here? Program errors. Vertex errors. And fragment errors. Undefined variable frag texture index. You are correct. That was the wrong capitalization. Here we go. Can't say I love it. Not great. You know, if we're honest about it, not fabulous. Not sure how we would have made that particular mistake here. Oh, not true. I actually do know how we may have made that mistake. Hold on one second. So in addition to those buffers, we also have these. And these buffers are, so if you look at how these textured vertices are specified here. So this is the p-value, this is the light UV, this is the UV, this is the color. Then we have the normal lightness of the vertex. Well, so that should be still fine, right? I think that should still all be fine. Are we getting any? We're not getting any errors though. Yeah, I'm not sure what's wrong with that. Let's take a look. Why are we getting that? Why are we getting a problem? All we did is add all we did is add vert light index, right? That's the, vert texture index. That's all we did. And is vert light count, is that even used anymore? Yeah, that's not. So vert light index and vert texture index are both just, okay, that was a mess up. But those look pretty evenly paired, so I don't know what the problem was there exactly. Okay, so it was just that one typo. So now we're specifying a vertex index in the vertex shader, but we're not actually using it anywhere. If we pop over to the renderer and take a look at where we would actually use this. So what would happen is inside our actual push quad, all of these would now have a texture index set to texture index. And again, we don't, much like light index and normal, we don't really need as many as are actually in here. So it's kind of messed up, but you know, again, these are things that we may or may not decide to optimize later because it does cost time to do them. So if we look at light index here, and texture index is going to be similar, where we just need to figure out what texture index it should be. And so what we can do is say, well, that should just be in the renderer texture. That's just going to be the value that it is, right? So if I go look at what we have specified the renderer texture to be, we just want that value to be directly usable in the shader from now on. So you see here we've got this handle. What I want to do is just take that handle and smush it down. So we're just going to compact the handle and say that's the value. And so then what we will do going forwards is we'll just say, oh, we'll just, make renderer textures be things that get that kind of smushed handle in them, and then we're done. Right? Okay. So what can we do now to sort of push ourselves towards that? Well, the first thing we have to do is we actually have to start using texture arrays, right? And in order to do that, we have to have a way of specifying textures as part of kind of one, a sort of creating a single texture handle that refers to like a deep texture that has multiple slices, right? So if we take a look at this here, what you can see is there's sort of this notion that we're going to call a slightly different function. And you can see here that there's like this notion of a layer count. So what would happen is we're still talking about 2D textures potentially. And they still have all the same parameters that we did have before. But what we want to do here is talk about this additional parameter that we're going to say allows us to specify multiple slices. And so when we call text subimage, we will also, to like update images out of this texture, we would also pass in an information about which layer we were targeting and other things like this, right? So let's take a look at those things in more detail. Where's our docs.g? So when we specify this piece of information here, right, you can see that this call is just going to specify like an entire cube because it's got the width, the height, and the depth, right? And there's nothing we can really do to adjust it. So in order to actually specify textures differently for every slice at separate times, we need a way to control the array, the layer information that we want to pass there, right? So what you can see here is this would let us do that, right? We could pass the z offset and the depth could still just be 1, so we could just do one slice of it. And what you can see is the target lets us differentiate between whether this is supposed to be a 3D texture that's an actual like voxel, or whether this is actually just a 2D texture with a bunch of slices. You know what I'm saying? So that's really what we are looking to do, is use this function to define different slices of our texture, each to be a completely different image. All right. So now GL text subimage, I don't even know if we've got that. That may be one that we have to call as well. But what would happen is when one of these textures gets submitted, Opengl allocate texture. So in here, what we would be doing instead of this call, we would actually be doing this call. To pass that in, right? Now I don't, like I said, don't remember if we have that. We do. So if we want to do this call, you can see here's all of our things that we need to pass. We need to pass the target. It would be a GL texture 2D array. We have to pass the level. Again, we're only going to specify 0 at the moment. We want to do bitmaps eventually, but not right now. X and Y offsets, are always just going to be the upper corner, but the depth, I'm sorry, the Z offset is going to be a certain layer, like which slice. So this is the texture index that we're talking about. The width, height, and depth are always going to be whatever the width, height are and 1. Now, we're going to have to, again, constrain the width and height to be something more sensible, potentially, although there's other things we can do there as well. And then finally, we need the rest of this stuff, and that's going to be the same as it was before, right? So we need this information here, red, RG, RGB, BA, whatever, right? We know the one that we're specifying is BGRA. That's always the way that we want to pass down our information. And we also know that we've got the type field is the same always. We don't have any other kinds of data. And then that's the end of it. So that's actually all we'll really need to do at the end of the day to get started, right? But the harder part now is going to be how we deal with when we call this allocate texture. We've kind of got to deal with another, not sure how to put this. We have to deal with the idea that we actually now allocate the texture only once, and then we're just putting things into these slices. So this isn't that hard of a change to make actually, so I'm just going to go ahead and kind of make it. But what I want to do is I want to kind of do it again like we were in 2 sort of baby steps. So the first step is I want to change the way that we're specifying textures to be feed forward, right? And this is the thing that I was talking about before, and basically what this means is we're just going to assume that there's a certain number of textures that the renderer handles, and that's the end of the story. So when we come through here and you do an initialization on the renderer, kind of like we have at the moment, where you need to say, here's how the renderer gets initialized. Let me see, where do we define that function here? It's in Win32, right? So this load render entry. Yeah. So this is what we're talking about. So when you go to load, you pass the max quad count per frame. What we want to do is say there's also a max texture count, right? And the max texture count is just going to say, here's how many textures you're ever going to talk to me about. You know what I'm saying? Like, you're never going to tell me about some other texture that's like, not within this set of textures. You're always going to say, if you told me 32, you're always going to talk to me about 32 textures. That's just what you're going to do, right? And so that's an additional piece of initialization information that comes through in the initializer. Then when we actually have Win32 init OpenGL, what we want to do here is when we do our initializations, we want that piece of information to be recorded. And I actually probably want this stuff to be recorded earlier than when these are actually, I probably want those to be set like right off the bat, right? So everybody else who might want to know about what these maximum values are, they can always count on them being set. And that way when we call OpenGL init in here, that will actually create those textures on the initialization call. And we're good to go from there. Excuse me. All right, so temporarily, like I said, though, I'm not quite going to do that. I'm going to go ahead and do something slightly different. Well, actually, you know what? I don't even think I do need to do something slightly different. I'm just going to just lean on the fact that Opengl already supports this and say, okay, if we do an Opengl allocate texture call here, what I want to do is I want to have those calls take a texture index. I want to assert that the texture index is less than the max texture count, and I'm just going to use it. So what I'm going to do instead of this stuff here is I'm not going to say glgen textures. I'm just going to use the texture index directly by saying this. I'm not going to call that. And just so we're going to leave 0 as a non-texture for now, just like I usually do. So all this stuff is going to get called as normal. And then in here where we specify this handle, I'm just essentially writing that texture index back through. All right. So this means this is not actually going to do this anymore. We're not going to have that. And in fact, what we're going to have is a thing where we just pass in which one of these textures we were actually talking about. And we could call this a renderer texture texture here. And maybe I'll just do this. Something like that. Okay. But it doesn't return a value. So then when we do manage textures, what we want to do is say in here where we were assigning the result texture, we actually want to do the opposite of that. We want to pass the result texture like so. And then when we go to do deletion, we don't actually really need to do deletion anymore. So I'm going to remove this path in its entirety, right? This just isn't going to be a thing. All right, so now we need, oops. I just need to put some of those things in here that I said that I had. So, you know, in here, there's a max texture count. Oops, texture count. I think that's all fine. And that's just a bigger, that was a 64-bit value. This does not return a value. Opengl allocate texture in this case, again, doesn't really have to do it this way anymore. So what we actually want to do is say that the Opengl, oops, no, that's not it, sorry. Opengl white bitmap gets passed in here. So we need Opengl white bitmap, in this case, to be equal to some handle value. In this case, let's just say it equals 1. Oh, and that's a pointer in the texture management code, which we don't need it to be anymore. So as far as Handmade renderer is concerned, when we have that texture op, the texture op here can just be that. And really, we could call this texture op allocate texture op update. And similarly, we can just say you don't deallocate textures anymore. You just update textures that you want to talk about. And it doesn't have a trim command, potentially, right? So maybe it just says, hey, here's a texture op update. And it's not really an allocation anymore. This doesn't really need to be here. In fact, it just looks like that. And we could choose whether we eventually want other texture ops, but it may be that then this just becomes welded together. We don't really need to do anything else. All right, so for the time being, that's just going to work like that. We need to pass how many textures we want here. We don't really need very many, but I'll just say 256 textures. So now we can see this is kind of nicer too, because like I said in here, now we just say which one of these we actually wanted. So we can say, hey, the texture handle that we're gonna talk about here is this one. And it doesn't have to be an address anymore. So that means that the load bitmap function gets simpler, which is good. So just continuing down with this code change. So now in here, what we need to do is this. And what we want to do here is just assign these values to things when we initialize them, right? So what I want to do here is actually just pick these out. And what I want to do is just set these to be equal to numbers that I understand. So I want to say like renderer texture, or texture handle, like this. And right now I'm going to kind of cheat and say that I know which one. I know that there's one reserved for white. But what I really want to do is move away from the renderer creating its own white bitmap, and I'd rather us just create the white bitmap. You know what I'm saying? So anywhere that we were, and I don't know that actually, to be honest. Okay, so we don't. Never mind. So I don't care about that because we don't use the white bitmap anyway. Okay. So let me look inside the Opengl. I want to look and see if this uses the white bitmap anywhere. It doesn't. Even better. So again, we can probably just get rid of that entirely, and then just inside your own code when you're using this renderer, you will create the white bitmap if you wanted it. It's not something that the renderer cares or knows about at all. So this is what this would look like. I want to make a little function inside the renderer code proper that's like, looks like this. Something like that. And that way those are wrapped just for the time being while we're playing around with it here. I'd like to make sure that we kind of know what's going on in that regard, right? Okay. So what I want to do now is inside Handmade Hero, when we use these should just be things that are assigned based on what's available in the bitmap system, what's available in the asset system, right? So what I actually want to do here is when we do a finalized asset bitmap, we're gonna want to do this in a better way just in general. But this bitmap texture handle is really just going to be something that's set right at the outset. So when we actually do that bitmap texture handle thing, excuse me, we're going to set that when we actually create the bitmap. So let me just go ahead and search for that here in Handmade Asset. So there's one use of it here. Here's the deallocation call. And again, that deallocation call is now going to be a different thing. It doesn't actually have to deallocate it. It just has to put it on its own free list, effectively. So it knows it can use that texture handle again. So we don't really need this to be here, is I guess the way I put it. So we just need to remember which texture handles we haven't used, but we're going to be able to collapse all this code down, so I'm not even really going to worry about that right now. So we don't need to do that just yet. This is not necessary. And let's see, init default renderer just needs to have one of these. I'm not sure what our next texture count should be. I don't know. If we assume that we're gonna have 512 by 512 textures, that means each texture is 1 megabyte. So I would think we'd want to use like a half gigabyte of texture memory or something. It's all we would really be using for textures would all be in this one place. I think that's probably about right. So I'm not sure. Let's set it to 256 first. But we need to feed that forward to the asset system eventually as well, because those have to line up. Max texture count. Okay. So now inside Handmade Asset, when we're looking at creating those asset bitmaps, whenever we go to load one of those, we need to actually get one of these texture handles here. So when we would kick off a load asset, when we would create one of these, so the finalize call, if you will. So when we would kick one of these off, what we want to do is at this time also assign it a place to go, right? So when we set up that texture op queue stuff in here where we have this bitmap, the bitmap texture handle wants to be set here. Right? And what we need to do is we don't want to always set it to 0. We want it to set it to something that hasn't been used yet. And so what we don't know when we start to go into this task situation here, we don't really know what textures are or aren't available. So we want to be able to figure that out dynamically somehow. So again, I'm just going to put a to-do in here for that. So we're going to want to do this sort of update the asset system as a separate pass when we go through and do the texture array stuff, because it wants to be aware of that, right? But so this texture handle here where I specify what it is, what I can do is just inside the asset system temporarily, I can just have a monotonically increasing value and just set that to whatever we set that to, right? So I can say like, this texture, or use texture handle, or next free texture handle, something like that. We can just say whatever the asset system is here, we're just going to use one of those, and off we go. And the renderer, by the way, will assert if that's not appropriate, right? We don't ever want this one to be 0, so we also should probably set this to what we want when we actually start. So when we are initializing the asset system and everything sort of gets started up here, I also probably want to do start with texture handle 1, right? And if we want white bitmap, I could even start with texture handle 2. And that's, I think, all we really need to do there. So let's just see where we're at in terms of actually reconstructing what we're trying to do here. I didn't think we had to do that. We don't have to use an unnamed generated by Opengl, do we? Aren't we allowed to use a name not generated by Opengl? I could have sworn that that you don't have to call gen textures. That you can just pass whatever handle you want here. That is weird. So that I'm not sure about. Did they change? They maybe changed that. You didn't used to have to do that. It's not a big deal, because it's pretty trivial for us to just work around that immediately. But I thought I wouldn't even have to do that. And I'm not going to leave this code path in, so I don't really care that it doesn't support it, but I thought that was something you could just do. However, it's pretty easy for us to work around that. All we have to do if we want to is instead of, and wait a minute, and didn't white bitmap not do that? Yeah, this call didn't have a problem with it. Maybe it didn't get there yet. But it's just a little bit weird, right? Because it should have been doing that. Anyway, if we don't want to do that, that's okay. So in here, where we do our Opengl init and we initialize this stuff for the first time, what we can do is just say, all right, this is going to be some kind of an allocation thing here, where we do a GL gen textures call and just get a bunch of these things. So temporarily, I'll just do one here, right? So when we call glgen textures here, what I want to do is say, look, put a bunch of texture handles into here for me. And then what I can do is when I do my allocate texture call, I should be able, when I pass the stuff in here, right, I should be able to just use the array that you told me, right? So I can just do like, okay, Opengl texture handles like that. So that should allow me to basically set these various texture handles to whatever I want them to be, right? And, you know, now we've got the renderer setting those textures, and that's what we want. Okay. So what we now need to do for our final step is change from using actual texture handles to just using slices into the texture array. So again, this should be pretty straightforward. We should just be able to do this, where we say, okay, we don't use texture handles anymore at all. All we really do when we allocate a texture is just update the slice. So instead of calling any of this stuff, what we're going to do is just do this. Actually, it's not a handle really anymore. So what we want to do here is say the texture handle should be lower than the max texture count, and then here we just have like a, we grab that handle out. It's just going to be this texture index, right? So that's actually how we're going to update textures from now on, where we do this handle is what gets passed down, okay? And so when we actually update this, the other thing too is the width and the height are kind of irrelevant. Like we don't really need to pass them anymore because they always have to be the same thing, but that's sort of a separate thing we can talk about a little bit later. Because we actually may need to do some UV updating kinds of stuff in order to get like rectangular regions out of our textures. So this would actually be the way that we would update this from now on. And this bind texture here would actually always, like always in all cases, bind just our giant array texture. So we would have that, and this would just be a single texture that we allocate at the beginning that just has all of the slices in it. However many this says there should be. So when we actually bind that texture and update it, we should be good to go. I believe we pass to that array 2D there, but let me just make sure. So we can. Yeah. There you go. So when we bind that text subimage now, we're just updating slices of that thing. So then if we just use this instead during startup to, you know, inside Opengl init, where before we would have been allocating all of these texture handles, instead of what we're going to do is say, well, inside the Opengl texture array, we know that we've got each of these textures packed into this one thing. So just bind it at the start, make a 3D image out of it, set the parameters that we want, and then finish up, right? So what we want to make sure we do here when we're doing this sampling too, though, because there's more to it than this, right? Is that we need to make sure that when we bind these textures up, we want to make sure that we set the filtering properly, because we just want them to stay within a slice. Like we never want them to kind of like sample outside of the slice or do anything like that. So when we actually create this texture array here, and specify the settings for it, this function we'll have to update in a second. This is going to be like a 0 data point or something. We're just going to set the layout of it. But what we need to do is make sure that we set these other filter parameters correctly for the texture arrays. Now, I have the array texture stuff up here. Yeah, you can see. I don't know if there's any other of these that we would actually need. Doesn't really look like it. So we may actually get away with just doing this and not really changing anything else. Yeah. So we might be able to just do something like that, where we said like, okay, let's look at GL text storage. We can just call GL text storage, set up the size that we want this thing to be, and then just call into it, making updates to the layers as we go. That seems fine. So here where we specify the 2D array, the MIP level count right now we're not going to have, but eventually I think we probably will. You know, Well, it's all right. Anyway, so in our GL text storage 3D call, we need to set the default, the format for it to be whatever our default sprite format is. And then our width and our height, we knew at the moment anyway, was 512 by 512. I think that probably has to be something that we pass in. Like, what do you want your texture size to be, if that makes sense? So we'll probably have to play with that a little bit more as we go. Probably pass in texture array dimension here. So we want to probably update that a little bit. But other than that, I think when we push these through, I think we're okay here. And then that way, when we're pushing these down, we can sort of go from there. I don't know if we have text storage 3D though. We probably didn't grab that call. I'm sorry, that parameter. Yeah, we didn't. So we need to grab those out, and but that's about it. So I can't promise I'll debug all of these today, but this is the basics of it. There's not really much more to do other than debugging it, and then we can kind of go from there. So let's see, texture stuff. Is there a place we put some of that already? Not really. So I'll put it in here. Looks like it would go somewhere in here. So we just need our text storage 3D now. And that's just the thing that says, look, I'm not going to tell you all of the actual layout of this thing. Like all of the contents of it. I'm just going to tell you how big it would be, and then I'm going to fill it out incrementally as we go. That's all that's doing, right? So again, we'll just put those in here. And then look at text subimage 3D. And that should be all we need. All right. So when we're binding these textures now, we, again, have the situation where we don't really need to worry about binding specific textures inside our draw elements loop. So if you look at what's going on here, we can now just make one call. And the idea is that we would just bind one texture array, and that texture array would not come out of there'd be no quad bitmaps or anything. That's just going to be deleted entirely. And instead what we would do is say we're always going to pass down our texture array as the thing that everything grabs. It'll just lemon grab the texture out of there. And then we just need to actually, in our shader, access that texture array using the indices that we get passed. And that's really the only thing we need to do to make the rest of it work. And all the infinite amount of debugging we're going to have to do to figure out why Opengl isn't working, because that's obviously also like 6 years of work. But in general, this is all we really need to do. So in order to sample it, you can see inside the shader, it should be pretty straightforward. It depends which one we're using. They don't really note it here. We don't care about the min-max because we're actually loading an int directly. So we should actually be able to do the correct texture fetch just in general. I don't know. Yeah, so we use a different sampler type there. So we should be able to just set that sampler type and go from there. So inside the Z bias shader, this one right here, here's the samplers. So this texture sampler is going to be one of these. It's going to be the 2D array. Is that capitalized? Yeah. That's our texture sampler. And our texture sampler is only used just to get the one texture sample, right? So we should be able to just, in that texture sampler, we should be able to just do the array sample here. And so if we look up the GLSL quick reference. The call for actually getting a texture array. Let's look at where the texture sampling is. No. Where's our GLSL calls? Here they are. So those are the types. Where is the texture call? Here it is. So right now we're just calling texture, and you can see here that like it's got a bunch of different kinds. So when we call texture, if we call sampler 2D array and we say here's the sampler, here's the vec3p, and then the bias we don't care about at the moment. So that number that we were passing it, the frag UV, is like insufficient. It doesn't have enough actual information there. So what we want to do is make like an array UV. So we want to say, look, there's an array UV, and that array UV is going to be the frag UV. Let me do this the way that they tend to do it, just in case. Cause them fits and starts here. So we're going to make the frag UV X, the frag UV Y, and then this actual Z component of the texture is going to be the index. Right? It's just going to be the frag texture index. Okay? And then I just have to figure out, okay, what do they want the coordinates to be for this? Because I don't actually know. It's just, so if it is just the layer, it's clamped. So it should be just that. Like that should be it. And then if we access that as an array, after the array UV, that should basically do it. So it's saying take the texture, go to this slice of it, and here's the actual fragment location of the thing. So let's actually see what we can do here. Invalid texture format. Invalid texture format here. Are you talking about BGRAEXT? I'm not sure what exact problem they have here. I need to do in debug mode to be able to inspect all those, unfortunately. So what's interesting is we did not get a problem for allocating our original. So we're only having a problem here. Why is our texture array set to 0? Did that not get initialized? I'm going to stop in OpenGL init. I'm going to switch to debug mode, and I just want to see where we're at. So there's a compile and debug mode. Let's go ahead and roll forward on that. And here's OpenGL allocate, the OpenGL allocation for, oh. Oh, duh. We still call it for this white bitmap. All right, so I gotta take that out as well. I don't want to see that call in there. So that's gotta go. But that should have nothing to do with it. That's just because it's getting called. Well, it might, actually, because if we haven't initialized this yet, you can't call that. Right. So in here, this is probably just complaining about the fact that our map count needs to at least be 1 for GL text storage. Go ahead and guess in there. So it seems to have liked that okay. We don't really know, though, yet. Whoa. All right. I was not expecting that to work the first time out. Yeah, that's kind of nuts. But that appears to have worked. Um, okay. Well, I assume we still have some problems in there, but somehow that actually worked, which is crazy. And I don't know what to make of that. I was expecting that to be a long slog. All right, well, here's our renderer running with correct textures, and it's running, I think, actually quite fast. I think that's probably within earshot of running at 60 now. You can see we've got some issues because our textures are not always, I think for textures that are, we're sending them down and they're always going to be blown out to the 512 by 512 size. So we kind of have some more work to do because we need to remember the sizes of things inside those textures, right? So we kind of need to do a little bit more work there, but that's pretty awesome that that just worked. I also wonder, I'm curious about, what's the GLGen bitmaps call? I was curious if we could call the generate texture map. We can't really though, because when you update one, we would only want to generate the bitmaps for one slice, and I don't think it would really allow that. Yeah. So we don't really want to call this. I was going to say we could try turning on MS, but we're going to have to send those down ourselves because we want to send them down per slice. And we'd want to send those down ourselves. All right, so we still have a fair bit of work here to do. We're not done, but I guess we did what I wanted to do today, which is get the texture arrays working. So Handmade Hero obviously is going to have some issues, which you can kind of see at the moment. Mainly that's just because we don't have white bitmap yet. But the real thing is just the texture sizes. So, you know, yeah, having the white bitmap be specified at some point, obviously necessary. Now let's just go ahead and do it. So if we got rid of white bitmap, let's see where that's actually being used. Okay, so let's suppose we just went ahead and specified everything here, and white bitmap has to go away. Oops. So like all this stuff, it's just got to go. Also, quad bitmaps is not necessary anymore either, right? Like all that stuff goes away. And so it's going to have to get that white bitmap from somewhere else, and that's the important part for our purposes here, right? And so that's what we'll be working on in a second. So what I want to do is, yeah, get rid of quad bitmaps, because quad bitmaps we don't want to use anymore, right? That just never wants to get set. That never wants to get talked about or set or anything anywhere. And then white bitmap wants to come from somewhere that actually is internal to the application. It's not something that the renderer provides for you. And looking this through, let me see, it looks like that's the only other thing that we really have to worry about, right? Yeah. So I think all we really need to do is figure out where else we're going to get that white bitmap from. And my suspicion is the best way that we could do that is in the renderer inside the game render commands. When you create one of these, if you want to provide a white bitmap, you can, and that would just be set in here. So all of these would just say, look, you're going to get a white texture out of here if there is one. We don't guarantee that there is. Someone can set that for you, but otherwise you just won't draw. You know what I'm saying? So all of these can just say, look, white texture. Oops, I missed one. And it's up to your application to make that if you want it, but we're not going to make it for you. And there are other ways we could do it. Wait, it's not a member of render group? I thought I just added it. Nope, I didn't. That was my bad. So that's just going to be something that the app can choose to supply on their own if they wish. Otherwise, it won't be, if that makes sense. So I think that's all I really wanted to do there. And then, when you create one of these render groups, if you want to specify a white bitmap, you can. Otherwise, you don't get one. And we can make one inside Handmade Hero to restore that functionality as necessary. So if we, look at the places in Handmade Hero where that's actually used. And in fact, since we actually do pass in an assets parameter for that, I suppose that's something that really should be set separately as well. Probably want to clean that up. Like, you shouldn't have to pass 0 to that. That should just be like a user pointer or something, right? But just looking at this as it goes through, you can see where these are set. What we really want to do is have that command be something that you kind of do in your app, and then you can set that white texture to whatever you want if you want to. So for example, inside our asset startup is probably the right place to do that. So inside here where we go ahead and set up the assets, what I would want to do is create the white texture here. So this is something where, we would push on a texture op to do that. So texture op. Something like this. So we'd say, okay, the texture handle for the white texture is going to be texture 1. The width and height of it is also 1. The actual data for that is just whatever our white texture is. So I have to put it somewhere where we know there's going to be a single piece of memory that won't go away, because we don't know when this texture op will complete, right? So that just allows us to create one of those, and off we go. So now there'd always be a white texture there. We also could just say, look, if it's just assumed that that's texture handle 1 all the time, or maybe that's just always texture handle 0. That seems even better. So we just assume that texture handle 0 is always the null texture in that sense. And then I think we're good to go, because then what we can do is inside Handmade renderer, when we do begin group, that will be what it's already always defaults to. So if you want to set that texture as white, you can, but you could also do something else, right? Okay. So this won't quite work, and the reason it won't quite work is because, again, it's only it doesn't record the sizes. But you know, we probably could fix even that if we wanted to. And the way that we would fix that is actually kind of interesting. We can, if we want to, encode in our texture handles what the width and height actually are, which I know sounds kind of weird. But if we want to, we actually can. So if you think about how this is working, we have like a 512 by 512 bitmap. And if we want to pick like subregions out of that, it's actually not that hard to do. What we can do is make the renderer texture actually embed that data with it. And then when we send down our actual sprites, they can just bake those sizes into their UVs. So for example, in here, when we actually have a renderer texture, if we look at what this looks like, what we can do is instead say, all right, let's just say that there's an index, a width, and a height specified for this thing. And, you know, I mean, it can look like this. And so then it's a 64-bit value for your renderer texture, and this is what it encodes. So then when you do texture handle, you would just say, like, hey, what did you want the width and height of your texture handle to be? And this actually is now just the thing. You don't need in the texture op to have anything else. So you just do this. Right? And I know this seems really strange, but just trust me for a second and watch how it works. So we've got a renderer texture. We just pack into 64 bits what the index slice is and how big we want it to be in the thing. And to be honest, we could even be fancier about that. We could actually pack an offset in here if we wanted subregions of the texture. We could get that fancy if we really wanted to. So this actually can be kind of flexible in that sense. And so then if we look at the texture handle call, what we can say is like, hey, pass me the index, then pass me the width and height. Once I do that, I now have all of the information packed into my texture handle that I actually need. And I can just force everyone else now to call it, to have to actually call it. If I look at the texture ops, now it's just this. It's saying like, here's where I'm going to put that texture. And so then we can just say, okay, here's the index. Let's just grab that index out. And in fact, while we're at it, we could just say, let's just use it. Here, we also know what the width and height are. So here they are. That's how we're going to update those pieces of information. And we don't need this anymore. And we can just go from there. Okay. So then when we talk about this thing where we pass Opengl Allocate texture, we can get rid of those two. Those don't exist anymore, and that's fine. And they don't exist here either. I don't really know what clear does in this case. Or who's calling it. But we can still do it. It's certainly not a problem. And then in here, when we're actually starting to use this stuff, this is where we start to actually have we actually have to do stuff, right? So here's our UVs that come in on the push quad. And what we now know is that these UVs are not necessarily correct because the size of the thing that we loaded in may not be the size of the entire texture. So we need to correct for those values by inverting the value that comes in. So what we first want to do is grab the index out this way, like so. And we probably want to do this to make sure that it doesn't ruin our day, if that makes sense. But then what we want to do is we want to come up with a way of processing that UV information into here. And we're going to do that in just a second, but give me one little scrimpus here to make sure that that's okay. So with this feed forward, what we do need to do is, since we don't know the sizes of these yet before we load them, in Handmade Hero we always do, but we don't know the sizes of these before we load them inside this app. What we need to do is, this won't be able to be feed forward in that sense. It will still have to rewrite just those pieces of it, right? So we would still have to do it this way, which I don't like. I'd rather do it where we can just do feed forward. But the nice part about that is, well, it's feed forward still to a certain degree, in that although this has to fill in the width and the height, it doesn't have to fill in the handle. The handle's always correct, right? So that means the multi-threaded part, it's still better than it was, even though it's not as good as it is inside the actual Handmade Hero code base, where we always know the size of something before we load it, if that makes sense. So anyway, that means we still do have to do this here. But that's okay, because really the only thing we're doing here is saying that the texture handle well, and I could do it this way. I'm gonna do a couple things here. I also want to do like I'm gonna call this a texture reference for now, maybe, or refer to texture. Something like that. So I'm going to actually, when we call this, I'm going to rewrite this here. I'm going to say refer to texture. I want the texture handle index. And I want the width and height baked in there now. Now that I know what they actually are. Like so. And then I'm going to use that. And that's the entirety of it. Now everywhere that was calling texture handle has to actually be like refer to texture. And these can kind of do this. I maybe will make it so you don't have to pass in a width and a height if you don't know what the width and the height are yet. So you can, if you want to, specify that. But I'm going to hold off on that just a little bit longer. Oh, you know what? No. I'm doing this totally wrong. This is way better API-wise. We'll just do it this way again. This is how we kind of wanted to do it originally, right? Just place this in here. And then what I'm going to do is say, okay, grass texture is 1, 2, 3, 4, 5. Get rid of all of those. And then the load bitmap call is actually one that returns a renderer texture just like we wanted it to originally. And then what you do here, this is just like the texture index, right? That seems much better. Because now what we can do is say, all right, the renderer texture equals refer to texture, And we know the texture index because it's been passed to us. And then we can just say that that is what we are returning. Much nicer. Much, 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 much nicer. That's definitely much better than it was. Okay. Conversion from S32, that's probably true. And in fact, these probably want to all be done sort of like this, where we can sort of assert them. And this way we can just test to make sure we haven't lost any important bits. No one should ever be passing us anything that big to begin with, and we'll have other things we want to check anyway, but it just, it's worth noting. All right. So now when we do that bitmap texture handle and we actually assign a new one to it, we want to assign the bitmap width and height at that time as well. So when we actually do a texture handle call, like this, in this case, we want to pass that width and height in. So we want to do it like this, right? Where we know exactly what we're doing here. Like so. And like I said, I'm kind of, I don't know what the name of this should be, but like, something like that. So that's everything I wanted to do there. And now when we run it, we should hopefully, if I didn't screw anything up, get exactly the same things we did before. So that should look like exactly like it did. And this should look exactly like it did, right? But now that we have bundled with the texture what section of the texture we wanted, which by the way would have worked for texture atlases too, if you wanted to. You just have to use an offset in there. Instead of an index. Then what I can do is just say, look, when we go to actually push out the quad, just scale the UVs that you were going to use, scale those down to use the width and height that we've placed in here for you. So here's all our UVs. I just need to know the inv width and inv height value. So whatever that UV was, that UV is 0 to 1 based on sort of an understanding of how big the textures were. But in our case, we know that we want to base this on a texture size, whatever these are. And this is something that we need to get information about. Like I said, later needs to be sort of passed into the render. But what I can do is just say, look, we know what our inverse like our inverse U and inverse V multipliers are. So I can just take the texture width and the texture height, figure out what percentage those are, and now all of my UV scale just works, right? I can just say, in fact, I can just make this a V2. Okay. Once I have that, all of my UVs can now be transformed directly. So I can do this. Like so. And now I know exactly, oops, that's supposed to be height. And now I know exactly what region of this larger texture array image I'm actually trying to fill, or actually trying to use. So now you see everything gets back up to the correct size that it was. And similarly, if I come in here to Handmade Hero, everything's right. Because now we're using the right size again for our UVs to pick out the places in the texture array we actually wanted. Make sense? So the only thing we have left to do is make that not be a magic constant. At the moment, I'm going to leave it a magic constant, just not a magic constant that's hidden in the code so you'll never find it again. I'm going to say that this is going to be called texture array dim. And then what I'm going to do is say, all right, that just gets stuck in here. Like so. And that way I will know that the other time that I used it here and said we should pass it in, I can stop saying that now and just say this instead. That way when we go to update that, we will instantly be able to search for everywhere that that occurred. And I think with that, we're now doing texture arrays. Happy birthday. Right? Our game still looks like poop right now because we haven't put any bitmaps in, but man, we're so ready to do that. Because now we're sending down bulk. Sending down stuff in bulk. So that's kind of cool. And our app over here is running quite nice. So I'm going to go ahead and go to the Q&A and wrap things up. Let's see. Are there any benefits to using pixel buffer objects for async texture transfers these days? I've heard that drivers copy texture data into their internal memory anyway, so the call returns immediately and behaves as if it were asynchronous. So half and half. Hold on 1 second on that. And let me explain one thing. So pixel buffer objects, I don't think you ever want to use anymore because you can just use buffers now, generalized buffers for these sorts of transfers. And that's going to be the better way to do it. But I just want to address one thing. So you are correct in that the graphics card, when you call a texture transfer, if you're like, I'm going to transfer this block, right? When you call that, it will first copy the block into its aperture for transferring the graphics card, which is memory that has been locked, so it's not virtual memory, it's actually physically addressable memory, so that the graphics card can pull it, and then it will kick off the transfer. So it is true that the CPU to GPU transfer will always happen asynchronously, in the sense that it's not going to sit there and wait on the call. Now, it's not asynchronous per se, because as soon as you use that texture, it's going to fence, I believe. So I think there's some blocking that happens there. But putting that aside. That said, that doesn't mean there's nothing to be saved by using a GPU side allocated buffer. A driver side allocated buffer. Why? The reason is because that copy from your memory to the aperture that can be used for the transfer GPU doesn't have to happen. If you allocate a buffer primed for that kind of transfer through OpenGL, put the memory in there to begin with, and then let it go, it may not have to do that second copy. So depending on the circumstances, you may be able to save a CPU to CPU copy. The CPU to GPU copy, yes, that always happens correctly either way. But the CPU to CPU copy, you may be able to get rid of. Martins was saying that in core profile, you still have to generate all names. It's only the compatibility profile that lets you do the push. That's too bad. I mean, it's like fine because we're not actually using it, but... What's the recommended way to deal with Windows doing an infinite window proc loop while moving or resizing a window. Just ignore the messages. I mean, take them and don't actually do any work. So yeah, I mean, there's something much less hacky than that. Like, I mean, note, we don't have any problem with that, right? Here's me moving the window around like, happy birthday. And it's still animating just fine. And the way we did that is we just don't really process paint messages. We just pretend we do. So we say, oh, thanks for the paint message. Great, we finished it up. It was good. It's really fun. Thank you, right? But we don't actually do anything there. And all of our rendering happens in another thread that's just constantly going, whether Windows cares or not. So we just put our renderer on a different thread, not the window thread, so that the window thread can lock up all day long and it doesn't really affect our game. That's just Windows being Windows, right? And Martin says you probably would want to replace GL text storage 3D with GL text image 3D because text storage is from OpenGL 4.2. I'll be honest, I'm not sure how to do it though. Can I just pass 0? Because I was going to do that originally. But now that we have it working, I can certainly try it. GL text storage. Yeah, because I wanted to use GL text. I wanted to use GL text image 3D in the first place, but I didn't think I could. I thought it was mad about that. So this one is, well, let me leave this in here. So in here we're passing, the level is 1, the internal format is this, which is what we're saying. The width, height, and depth is exactly as it is. The border is 0. Format and type is this. So this right here would be XBGRA. Right? Or GL BGRA Ext, I believe. So that's what we would call here, I think. Just don't know if it will work. Invalid texture format. So what would I have to tell it in order to get it to be okay? I mean, maybe this can just be something else. I just don't know how to make it work is the main problem. Like, I don't know how to get OpenGL to be happy with that. If you have suggestions, Martins, I am all ears. Because I'm just not sure how to make it work. Do you still multiply the offset in the GL draw elements base vertex call? Because I never do it and never had any problem, so I don't understand what's going on. Do you still multiply the offset? Let me just see which multiply you're probably talking about there while we wait for Martins to tell us the answer of how he thinks GL text image could work. Are you talking about this? Let me read the docs. We may be passing that wrong and we wouldn't know, because unless we really look and see, it's possible that we could be wrong about that and not know. Let's just look. Problem here is that we're going to have to find docs that actually talk about how that offset works. And that's easier said than done. I don't see any answers from Martins, so I guess I'm not sure. Yeah. So let me go ahead and just take a quick look at that draw elements base vertex. And I'll look at the spec for now. Oops. Didn't mean to actually close that. Don't suppose this says. Here's a spec. So void star indices, it looks like without the base equivalent to the commands, if the resulting value is larger than the maximum value for the type, it would behave as calculated as courtesy. The operation is undefined, some would be negative. We need to find the we need to find where this would actually be talked about, probably in the element array buffer. Source indices from the buffer object whose name is bound to element array buffer using their indices parameters as offsets into the buffer object in the same fashion described as 296. Blocks words a buffer binding is added to the client stage. Okay, comments to specify location targets buffer blah blah blah. Pointer command copies value array buffer binding corresponding to the client state blah blah blah. Rendering commands draw arrays and defined. Random previously defined where data and when an array is sourced from buffer object, the pointer value of that array is used to compute an offset in machine units. So I'm pretty sure it's time. It should be times U16. Oh, Martins wants to look at the call that fails. You're talking about this one? It's this one, right? So what happens is if we call this, then our subimage call fails. So if we call text storage 3D, then our text subimage 3D call succeeds. If we call text image 3D, right? So like for example, if I call text storage 3D, oops. If I call text storage 3D, then what happens is everything works just fine, right? if I call text image 3D like this, and it doesn't seem to matter what I'm passing here, I tried passing different things, then what happens is I get a crash on on this call. So when I attempt to actually specify a slice, it doesn't like it. And it says that the type and format combination are not valid. But that's on the other call, right? So I'm not sure, I'm guessing that just these two things have to be set differently, but I'm not sure exactly what they need to be set to. Originally what we tried is having them set to the same thing. So where we actually specify right here, we tried just saying, look, it's going to be BGRA X'd. That's the format. And it just doesn't like it. So I don't know if it just doesn't like, maybe this just has to be something else, but I'm not really sure what makes that erroneous, because this is just the submission. This is the sprite, this is the format right here, right? So I'm not sure why I'm even having to specify that, because I don't need it to. So it may be that what I need to do is tell it, yeah, I'm not sure. Maybe I just need to tell it something different. It needs to be GLRGBA or whatever. Value does not matter because it is for the last argument pixel data, which is null. Yeah, but that's not true, right? Like, I can set it to RGBA and it doesn't have any, it doesn't work, right? Now, maybe if they're both set to RGBA, which would give us incorrect results, but maybe it wouldn't halt the driver. No, that doesn't work either, right? So that's why we were calling the storage function, is because that was actually what works. And I would be happy not to call it, but I don't know what else we would do. Yeah, correct. You can pass anything you want here. It doesn't care. It's this call that fails, and I don't know what I could possibly pass that would get this to succeed, because we've passed both of them and it doesn't work, right? Makes sense? So I don't know any combination of these two that would work. Obviously I can pass the same thing to both of them, like so, where they're both getting RGBA. So no EXT in this case. And it does not care. It's the same problem, right? So it ain't that. I would have assumed, and would have is to use the term lightly here. I would have assumed that this would work only in the sense that the reason I immediately went to text storage 3D is I remember having this problem in my own. I think GL text image 3D is the failing call. I don't think it is. But we can double check. So, I mean, it could be that it's just delaying the error report, but it's definitely not where it fails. So I'm probably going to call it for now. We can figure out why that's happening some other time. But Martins, I don't think what you're suggesting actually works, right? It's you have to do something else. Not sure what, but something. If you don't want to call text storage, maybe you got to call GL text image 3D in a different way. And just to be clear, this doesn't surprise me. I had the same problem in my code base. In the 1935 code base. I remember specifically having this problem. I should go look to see if I ever solved it without a storage call. I might have, and just forgot what the answer was. But I remember this specific problem where it's really obtuse what has to happen here. And I don't remember what the answer was, if there was one. Yeah. All right. I'm going to wrap it up. We can leave this in and just say so we'll give that a shot separately and just see, you know, if we can figure out what's going on there, like why it's busted. All right. All right. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. You don't even need the /game. You can just type it like that. And it comes with a source code. So if you want to play around with it at home, maybe you want to figure out how you actually have to call GL text image 3D in the magical set of fantastical OpenGL parameters, most of which are very poorly specified. Which one will magically work? And I know what you're thinking. Casey, invalid texture format is a fantastic error message that tells you everything you might ever want to know about why it failed. And you're right. We're just kind of dense for not knowing. We're going to be on break for a little bit. So I'll be back in a couple weeks' time. I will be speaking in South Korea in 2 weeks at the Busan Indie Connect conference in Busan. And so if you happen to be in the Asia Pacific region and just fancy a trip to Busan, or if maybe you live in Busan already, check out that conference. It's Busan Indie Connect. And also, not just me, but Chris Hecker will be speaking there as well. Some of you may know him. I think he's been mentioned before on the stream. He's a person who... no, stop. Oh my God. Okay. Websites that play music by default, don't really care for them. If you want to turn your sound off and then go look at their website, you can. I've shown you how to get there. I will never be going there again. Okay. Anyway, Chris Hecker will also be speaking there. He's what I was trying to say before I got blasted with music, is he's the guy who does Spy Party, and he's speaking there as well. There's also a couple other speakers who I don't think they're people who I've ever personally mentioned on the stream or anything, but they obviously have other speakers speaking there. So if you want to see me speak at the conference, or maybe you want to see Chris speak at the conference, or maybe one of the other, if you can turn off your sound and go look at the other speakers who are speaking, might be interesting to you. Check out that conference. It's coming up in 2 weeks. Okay. Until then, if you would like to watch old episodes of Handmade Hero, you can always go to the watch page. It's got old episodes on there in a really easy to search format, so you can jump around. It also has a schedule, so as soon as I post schedule for when we will be returning, that's where it'll be. We also have a fund page if you want to support projects related to the series, like the episode guide you'll find on the watch page that other folks do, not me. Check that out, that fund. It's a cool place to contribute. That's about it. If you want to see what else we're up to at Molly Rocket, you can always click on the Handmade Hero head. It'll jump you right to our other sites of the other stuff that we're working on. Or you can always sign up for our mailing list right down at the bottom. It's pretty easy to do. That's it. For the next few weeks, I'll be back here once my voice recovers and after the Busan conference I guess we did texture arrays. All right. So I'll be back to do a few more things on the renderer and sort of harmonize the asset system with the renderer, and then we should be good to go. We can start decorating our world with wall textures and little other characters and stuff like that. All right. Hope everyone has a good break, and I'll see you when we return. Take it easy, everybody.